Hey guys, all right. Welcome back to 4.5. Let's start with differential. Let's define that really quickly. Let y equals to f of x be a differentiable function. Differentiable function. The differential dx is an independent variable. Okay, so differentials. So let y equal some unknown function. Let's call it f of x. Be a differentiable, oops, there's a missing L, function. The differential dx is an independent variable. The differential dy is dy equals f prime of x times dx. dy depends on both x and differential dx. Okay. So let's try example 5 and apply this rule. Example 5, for each of the following, find dy, and b, evaluate dy for the given value of x and dx. So example A, and I forgot to give you what x is. X is going to be at -2, and dx is given to you at 0.1. So let's find dy. Well, we do it normally. We already know how to find the derivative, dy over dx. Okay, so dy over dx is, let's use the quotient rule. That means u prime, that means on the top, u prime times v minus v prime times u all over 1 plus x squared. With that said, we are going to have 2 times 1 plus x squared minus, this is, oh, what is that? What did I write right there? This is supposed to be 1 plus. So the derivative of that is going to be 2x times 2x all over your denominator, which is 1 plus x squared. Let's keep on going. We are going to have 2 plus 2x squared minus 4x squared all over 1 plus x squared. That will keep on going to give me -2x squared plus 2 all over 1 plus x squared. Now, this equals, oops, this equals dy over dx. Okay, I'm only interested in dy. See this right here? So all you have to do is multiply both sides by dx. It's that easy. So that means dy is -2x squared plus 2 all over 1 plus x squared and then times dx. So that's what we box up for what part A has to be. That's part A. Voila! Okay. It's that easy. Now part B, we just have to plug in what x is and what dx is. So give me the change in y. dx is a small change in x and dy is a small change in y. So let's plug it in, part B. B says, let's plug in -2 for x and 0.1 for dx. All right, slowly, let's go. dy is -2 times -2 squared, because that's what x is supposed to be, plus 2 all over 1 plus negative 2 square, all of that square. Work that out first, and everything is going to be multiplied by 0.1, which is dx. Okay. Now, on the numerator, that will give us a negative 6 over, on the denominator, that will give us 25. All of that need to be multiplied by 0.1. So the change in y is a negative 0.024. So that is what dy is. dy is a small change in the negative direction. Okay, and that's what we were asked to do. It's not very difficult because we already know how to do all the derivatives already. Let's try it again with example 5b. And again, it looks like I forgot to give you what x values was supposed to be. X will be 0, and dx is going to be negative 0.2. Let's do dy dx, which is the derivative. dy over dx, I'm going to use product rule and chain rule. U prime is going to be 1, so now I have 1 minus x squared plus x times the derivative of that radical 1 minus x squared, so it's going to be half times 1 minus x squared to the negative half power. The chain rule says I need to multiply by the inner. Okay, all of that right there. Let's simplify that really quickly. From there, this becomes 1 minus x squared plus this right here, and that guy right there becomes a negative 1. So okay, let me fix this. So this looks like a negative half, but that's not supposed to be. It's supposed to be a negative 1/2 as an exponent. All right, so that's going to be negative x squared in the front, and then I'm going to write this as a square root of 1 minus x squared, like that. I would now find a common denominator, so that means 1 minus x squared minus x squared all over common denominator of 1 minus x squared. Let's simplify that some more. This is negative 2x squared plus 1 all over square root of 1 minus x squared. So this is what my dy over dx equals. I'm not looking for dy over dx. I'm looking for dy equals. So we are now going to multiply both sides by dx to get rid of the denominator. Well done. Okay. So part A, answer dy equals negative 2x squared plus 1 all over square root of 1 minus x squared. And you can stick the dx back here. If you feel more comfortable, you can put quantity around the whole chunk. Either one, it's going to be just fine. We have one answer. Now we just have to plug in our values and find out what dy actually is when x is 0. So B, when x is 0, negative 2 times 0 plus 1 all over 1 minus 0 is 1 times negative 0.2. That will come out to be a negative 0.2 because 1 divided by 1. So right now, the change in x, one is a negative 0.2. At 0, the change in y is the same thing as the change in x. Beautiful. Well, guess what, guys? That's the end of example number 5. It's an egg roll.